and also have opportunity of participating in the live teaching. The only difference is that they will not be able to interact if we need to. So I'm starting the course teaching with what you know. And thereafter, we're going to move to maybe few things that are new. But for now, most of the things we'll be teaching you are some of the things that you know already. Let me also tell you, we are going to send a PDF version of our lecture notes to you. But we're going to advise you to try as much as possible to participate in our lectures. Thank you. So let me commence. Science and technology is the first topic. And the question we ask ourselves is, what is science and technology? So these are the outlines that I'm going to take you through for the next 1 week or so, for the 3 lectures that we'll have for this week. Hopefully, we'll be able to finish all this. So we're going to ask ourselves, what is science? And without any doubt, you know, science is about discovering new things about nature and about how nature works. You also agree with me that science is exciting and dynamic process for discovering about nature and the universe. And we incorporate the knowledge of science to do a lot of things. So what is science? Science is all about learning new facts. For instance, how plants grow. Constituents of petroleum, for instance, you know, when you talk of petroleum, petroleum is just more than what you know as petrol. In petroleum, you have petrol, you have crude oil, you have diesel, you have asphalt, a lot of things. Science is also about solving problems. And in solving problems, we always ask questions, asking questions, collecting information, finding answers. And science is about inventing things. Science is about inventing things. TV, laptops, gone are the days when you weren't alive then. Television used to be black and white. But these days, as a result of the work of scientists, we now have what we call color television. And we have different types now. Plasma, we have OLD, LED, and the rest like that. So science is about inventing new things. Yes, the process of science is exciting, complex, and unpredictable. You also agree with that. You cannot be too sure of what you're going to get if you mix things together. It involves many different people engaged in many different I want to be able to see the Zoom. Yes. So this process of science is exciting. When you work in the lab, we're always happy to see what we are able to do, but it can be complex at times, and sometimes it's not predictable. Science is not just for one person. It involves many different people engaged in many different activities in different orders. Students, science is based on fact, not opinion or what you prefer. No, science is not that. It's based on facts. And what is technology? Technology is the practical application of science. The engineers, they always apply the knowledge of science. So sometimes you can say that technology is applied science and science is applied technology. So technology is the application of scientifically gained knowledge for practical purposes. Building bridges is all about technology. Technology is about using scientific discoveries to make practical structures and devices for society. So when you talk of fundamental laws, scientists will put that together. But the technologists, the engineers, the technologists will now do what? We put that scientific discovery into practical structures and devices for the use of the society. So you can say technology is used to advance scientific knowledge. Technology is the innovation, change, or modification of natural environment in order to satisfy perceived. Oh, okay. Sorry about that. I didn't copy the Zoom link, the YouTube link for the student to see. I'm sorry about that. Thank you for informing me, sir. Sorry about that. And I apologize to the student. But I can tell them they've not missed anything. The YouTube link has been sent. The YouTube link is now available online. Please send it. Class reps should send it to others. Thank you. I'm sorry about that. I was just interested in pushing the note. So technology is the innovation, change, or modification of the natural environment in order to satisfy human wants and needs. It's also a process by which humans modify nature to meet their needs and wants. Now, we've given definitions of science and technology, but it is important to go through scientific methods. What are the methods that scientists always use? Scientific method is a logical, systematic approach to the solution of a scientific problem. In science, nothing is ever proven once and for all. You know, when we started chemistry, what we were told then was that atom is the smallest indivisible particle. But now we know that atom is no longer the smallest indivisible particle. So this is agreeing with that information now, that in science, nothing, hardly anything is ever proven once and for all. And you must also know that science is not about a particular method, but rather an attitude common to scientists. And what is that attitude? Attitude is that of inquiry, making inquiry about something. Oh, when you are hungry, what do you observe when you are hungry? Then you make inquiry. Then you carry out experiments. And because you are not sure of the final answer, humility before you know the facts. You are not sure. If you don't carry out experiments, you cannot know the facts. So humility is very, very important. So that's the attitude of scientists. So what are the steps that scientists always take to achieve these expected results? Some of the results that we know, what are the methods that scientists have been using? They always observe things. So observing things is one of the methods. Then proposing and testing hypotheses. And from there, they develop theories. We're going to look at these steps in details. And some of them we are even going to expand more than what you have now. So observation. An observation is something you notice when you are hungry. Some will tell you when they are hungry, they don't always get themselves. Their body will be shaking. And when they are hungry, when you are hungry and you are able to see a good food, your body will be okay. So an observation is something that you notice. It may be casual or even accidental. But when it's formal, then we talk of experimental data. It may be formal. And when it's formal, that is a kind of observation where you carry out experiment. Oh, you are hungry. When you dance, it's going to take care of your hunger. That's an experiment. And you'll be able to write something about it. Or when you are hungry, you get correct food and you are happy with it. So you can carry out. So when you make it formal, you can make your observation to be formal. And so these are some of the steps that scientists always take. Not all observations are correct. People make mistakes. You agree with me? There is this myth that says when rain is falling and sun is shining, the lion is giving birth in the jungle. Is that true? To scientists, we don't believe in that. It's just an observation, but it's not correct. So people make mistakes when they observe things. And one method that scientists always use is when they observe things, they try to repeat it. When they observe things, they try to repeat it. And they allow others to repeat it as well. And so, therefore, the condition for a scientific observation is that it must be repeatable. It must be repeatable, sorry. It must be repeatable. People should be able to repeat it. Non-repeatable observations are called anecdotal evidence because it's not repeatable. So you must know all this. And when we make observation, or we make an observation or observations, we try to know properties of things. And in doing that, we use our senses. Sense of taste, smell, touch, hearing, and sight. When we use our senses to obtain information. So it's important. Then the second thing is that we always ask questions. We ask questions like, for instance, you ask questions like, why do plants grow? So why does rain fall? Scientists will ask questions like that. And they form hypotheses, a tentative description of what's been observed. And they try to make predictions based on that hypothesis. They test the hypothesis and predict using an experiment that can be reproduced. So we're going to dwell more, on hypothesis. We're going to analyze our data and draw conclusions, accept or reject the hypothesis. So we ask questions, it puts hypotheses together. We carry out experiments, several experiments, and analyze the data we obtain from the experiment. And from there, we can draw conclusions. Then our hypothesis, we can accept or reject it. We reproduce the experiment until there are no discrepancies between observations and what we can call theory. So, we want to look at the various methods now in detail. So one of the first method that scientists always use, and you must follow the order, is to ask questions. So we develop a question that can be solved through experiment. I carry out experiment. And scientific methods always start with how. You ask questions about something that you observe. How, what, when, who, which, why. Things like that. Why do plants grow? And in order to help us in science, we don't just start our research. When we ask questions, then the next thing is we'll go and look for information to know if people have done something on it. That will help us to start quickly rather than starting afresh. And one of the reasons why we also do that is not to repeat the mistakes from the past. Then we form an hypothesis, a hypothesis. And what is hypothesis? Is an educated guess about why something happens. So it is an attempt to answer a question that can be tested. A good hypothesis allows one to make a prediction. If I do this, then this will happen. For instance, you're going to see an example later. You want to read at night, and there is no light. And so you need a torchlight. And when you look at your torchlight, you try to switch it on and no light. Then you ask yourself, you ask a question, what is the problem with the torchlight? And the next thing, you can now form a hypothesis. If I put a battery, what will happen? So you can always form your hypothesis easily. Then you test your hypothesis by carrying out experiment. So by putting battery in that torchlight, you'll be testing your hypothesis. So experiment tells whether prediction is accurate and the hypothesis is supported or not. Experiment should be repeated several times to make sure that the first results are not by accident. When you are hungry, if you eat food, it's going to take care of your hunger. You ask another people to test it. You ask another people to test it and carry out the experiment before you can now conclude. And whenever you are hungry, eating food is the best option to eat. Then some other students will also tell you, oh, okay, no, when you are hungry, eating food is not the answer, but rather dancing. So you carry out experiment and see whether eating food is what is going to take care of your hunger, or writing or dancing. A student just told me now that I did not record again. Well, I decided not to record this, but you have the online YouTube that you can access anytime you like. In addition to that, the hard copy of this, I'm going to send the soft copy of the lecture notes to you. So if your prediction is accurate, hypothesis is supported, then you are supposed to communicate the results. So we analyze our data and draw a conclusion. So we analyze the data, we check the data we have, if it supports the hypothesis or not, and we can now communicate. If the prediction is not accurate, the hypothesis is not supported, we still need to communicate the result of the experiment so that some people will know later and they will not make the same mistake. And we now go back and put our hypothesis again together. We put another form of hypothesis together. And at the end of the day, we'll be able to come up with something meaningful. Then when we've done this, we've analyzed, we've followed all the steps that I've highlighted, then we must communicate our results. And we have different ways of communicating results. Either we make a small display on a board, or we publish it in a scientific journal, or we present a poster at a conference, or we do oral discussion. We discuss during talk at a scientific meeting. Well, when we go for conferences, we have opportunity of presenting our work in a poster, or we do oral presentation where we talk about what we've observed, what we've done. And whether you get the expected result or not, it is compulsory to always communicate the result that you've obtained. So in science, findings are communicated regardless of whether or not they support your original hypothesis. You must always communicate the results that you've obtained. Now, thinking like a scientist. How do you think like a scientist? Observation. Suppose you try to turn on a flashlight. Oh, I don't even know it's there. You try to turn on a flashlight and you notice that it does not light. Then you must test your hypothesis. If you guess that the battery in a flashlight are dead, then you are making a hypothesis. Then, so a hypothesis now is the proposed explanation for an observation. What you observe that you try to put on a flashlight and you observe that the torchlight did not give any light. Then you guess that maybe battery is dead. By guessing that maybe the batteries in the flashlight are dead, then you are making a hypothesis. So you try to propose an explanation. So if I put a battery, you remember I said for hypothesis is always, you start with if, what, who, where, something like that. So if I put a battery in that flashlight, what is going to happen? A hypothesis is a proposed explanation for an observation. So, a question for all of you straight away. What is a hypothesis? Send your answer straight away. Tick, tick, tick. I'm waiting for you. Tick, tick, tick. I'm waiting for you. I hope the people on YouTube can see the information clearly. We'll get feedback after today's class so that we know how to take care of them very well. So I can continue. I can't see. I'm trying to look at your responses to see if can you see my response? I can't see your responses. Shemilore, I don't think I want any of you to, because I have 300 students, I don't want disruptions. That's why I've decided to mute all of you. So please, what's your answer? Send your answer. Please put down your hands, those that, so that we can organize. I'm going to get feedback from you later, but for now, I just want to see what I can do to get. But send a message. Just one of you should send a message. I hope you can hear me clearly. I'm looking at the chat box now. I can't see any response, yes or no. Just type. Okay, maybe I've muted all activities, which is fine for me for now. Okay, so let me continue. So, what is the hypothesis? And straight away, what's the answer? I will check the answer later. And that's the answer. Is a proposed explanation for observations. So, how do you carry out the experiment? Replacing the batteries is an experiment, a procedure that is used to test a hypothesis. Now, you also need to know something. Variables. When you carry out the experiment, the variables that you change during an experiment is referred to as independent variable. So we can ask you, and dependent variables. The variables that is observed during the experiment is referred to as dependent variable, or the one that is responding. So we can always play with all that. For the results of an experiment to be accepted, the experiment must be repeatable. Yeah, that's the word. Must be repeatable. We should be able to produce the same thing. If it's done in Nigeria, you go to America, you carry out the same experiment, you should be able to get the same thing. You go to London, you go to Kafanshan, you should be able to get the same results. And that's the reason why we always publish our results. Because when you publish it, others will look at it and agree or disagree with you. Then it is also very important to collaborate and communicate our results. So what role do collaboration and communication play in science? It is very, very important. If you don't collaborate, look at, I know you guys always watch soccer, football. If one player decides not to coordinate with others on the field, then they will never achieve the expected victory. But when they all come together, they play as a team, then they always get good results. So that's the reason why you as a scientist, in your future work, you must make sure you collaborate, work together with others so that you can get good results. Can see we are thinking like scientists because we know you guys are all scientists. And you must also know that sometimes when we try to test our hypothesis, the experiment is not always easy. Sometimes it's difficult. At other times, it is impossible. Like, how do you determine that atom is the smallest indivisible particles? You cannot carry out any experiment. It was so difficult at that time to carry out any experiment. And that was why maybe then Dalton gave that information that atom is the smallest indivisible particle. And now you can see, then it was not possible for them to see atom. Atoms are molecules which are some of the smallest units of matter, cannot be easily seen. So sometimes in science, we use models to study reactions so that from the models, we can put some things to information together to be able to write our conclusions. So instead of struggling to do the impossible things, we use models And from that, we can carry out our conclusions. We can put our conclusions together. Now, once hypothesis meets the test of repeated experimentation, if you carry out several experiments and you are satisfied with the hypothesis that you've put forward, then you can raise that level of hypothesis to theory. So, in developing theories, at this stage, I'll be looking at hypotheses, theories, and law. They are not the same. Hypotheses, theories, and laws. So, but you can see hypothesis is, once hypothesis meets the test of repeated experimentation, it may be raised to a higher level of ideas. It may become a theory. And what is a theory? A theory is a well-tested explanation for a broad set of observations. And there are times when scientists will tell you that a theory can never be proved. They are not saying that a theory is unreliable. But what they are saying is that a theory may need to be changed at some point in future to explain new observations or experimental results. And you agree with me again, that was what was done with Dalton's law. Dalton's law. Dalton's theory, which says that atom is the smallest indivisible particles. But now, with the knowledge that we have now, we know atoms is no longer the smallest indivisible particle. So we did not discard the theory of Dalton, but rather the information we got from the theory of Dalton was used to now explain some other things that we know now. So the three of them, how do they connect? Hypothesis, theory, and law. So a hypothesis is a prediction that can be tested or an educated guess. Is a tentative explanation or idea about how things work. Is a statement that can be tested. Is a statement that can be tested. If you cannot test your hypothesis, then it's not known to science. It must be tested. It must be tested. Why do plants grow? And you say, okay, maybe when they are exposed to sunlight. So what are you going to do? You carry out. If plants are exposed to sunlight, then you carry out hypothesis, and from there, you develop the experiment you're going to use to do that. And at the end of the day, you come up with what you can call data that you can now use to make your conclusions. So, hypothesis describes what you expect will happen in your study. It is a tentative statement that proposes a possible explanation to some events. A scientific hypothesis must be testable by observation. There must be observations that we can make to tell whether the hypothesis is correct or not. If you cannot test your hypothesis, then it's just a speculation. And so you can see hypotheses play a strong role in the scientific method. Because when you formulate a question, you make a testable prediction, carry out experiments, and then analyze the data. For hypothesis to move to higher level, it must be tested and retested many times before it can be accepted to be true. It must be tested and retested. I emphasize that. And that will now guide you to further work. Theory. A scientific theory consists of one or more hypotheses that have been supported with repeated testing. It's not a wild guess. Scientific theory is not a wild guess. Oh, when rain is falling, Abi, and sun is shining, lion is giving birth in the jungle. That is not science. That is not science. In science, we put our hypotheses together and carry out several tests on it, experiments. So when rain is falling and sun is shining, lion is giving birth, is a wide guess. It's not scientific. It's not scientific. It must be known. Theory. It must be consistent with known experimental results. And it must have predictive power. It should be able to predict something for you. And as new knowledge is gained, theories are refined to better explain the data. And I've cited the example of Dalton's atomic theory. As new knowledge is gained, we try to refine our explanations. And theories are widely accepted as being true. To remain a theory, yes, it must never be shown to be wrong. If it is, then it's disproven. Then theories can also evolve. That's what we know about atomic structure. And that's a topic that is coming after this. I'm going to send the course outline to you as well. Theories can also evolve. This means the old theory wasn't wrong, but it wasn't complete either. And that is what happened to the Dalton's atomic theory that I've used in this lecture. So a theory is a well-substantiated explanation of some of the aspects of natural world based on body of facts that have been repeatedly confirmed through observation and experiment. So through repeated experiments based on carefully designed hypotheses, then we get what we call theory. So you should be able to use it to make predictions. And that's why people that always give something about weather report, they're able to do that because they base their report on some of natural events that has been happening, and based on some laws that are some scientific laws, hypothesis that has been put forward, they've been able to use it to accurately predict events about weather. And you can see a simple way of thinking about a theory is that it is what we use to explain the facts that we observe in the world. Generally, what we know is that when you see that there is heavy cloud, then we say, oh, most likely rain will fall. And scientists will now go beyond that. They always carry out series of experiments after putting a reliable hypothesis or hypothesis, then they will carry out tests on the hypothesis, and from that results, they will be able to predict. And so theory is what we use to explain the facts that we observe in the world. And as experimental evidence accumulates, we can become more confident that the hypothesis is true. So your theory is linked to a hypothesis. So theory is just giving additional information that is a synthesis of well-tested hypothesis. And some of the examples of theories that we know: theory of evolution in biology, theory of relativity in physics, atomic theory, quantum theory in chemistry and physics as well. Then sometimes physical theories tend to be highly mathematical in nature. For instance, the quantum theory is highly mathematical in nature. So some of them are highly mathematical in nature. And so, in fact, some of the information from quantum theory have been developed into what we know today as computational chemistry. Then scientific laws. A scientific law is a powerful summary of many facts. Laws describe what happens. They don't generally explain why they happen. So you must be able to differentiate between hypothesis, theory, and law. Laws can be expressed conveniently in mathematical form. For instance, Boyle's law. The volume of a given mass of gas is what? You know it. You can express it mathematically. But theory cannot be, you cannot do that. But it can be mathematical. But for law, you can express it mathematically. And it's also based on repeated experiments that describes some aspects of natural phenomena. Law are often expressed using mathematics. It should be noted that a theory can never be upgraded to a law, as they are completely different things. Theories and laws may have to be replaced as new evidence becomes available. So law generally rely on mathematical equation, often expressed in a single expression. PV is equal to nRT, Heidegger's law, D'Alembert's law are examples of laws. Laws are accepted as being universal and are the cornerstones of science. You must note all this. Some of the laws that we also know: thermodynamics, laws of thermodynamics, Boyle's law of gases, Avogadro's law, etc. How are they related, the three of them? How are they related? A theory is more like a scientific law than a hypothesis. It is an explanation of a set of related observations or events based upon proven hypothesis and verified multiple times by a detached group of researchers. People can decide to carry out, once they have information about what you're trying to do, they can try to verify carry out the experiment in America. You also have some people carrying out same type of experiment in Nigeria, and they can come together later to agree or disagree and put their information together. So a theory is an explanation of a set of related observations or events based upon proven hypotheses and verified multiple times by a detached group of researchers. A law governs a single action, whereas a theory explains an entire group of related phenomena. One scientist cannot create a law. He or she can only create a hypothesis. One scientist cannot create a theory, sorry, but he or she can only create a hypothesis. A scientific hypothesis is a testable explanation about some phenomenon. This could range from explanation as to why apples fall from trees, to why Homo sapiens walk upright on two legs, and well beyond. My watch is like 1:10. I think we can pause here while I allow maybe one or two questions. Participants. Yeah, thank you for your, I will have a look at all the, both online, Zoom line and the YouTube line. I'm going to look at those that have attended and note these as part of what we're going to use as attendance. We want you to attend our lectures. Let us have responses. Tell us what we are not doing right. Commend us if we've done it right. And let us see what we can do to help you. Please, I also need to let you know, because of the number, because I don't know, last year we had about 3,500 students. This year, I'm not expecting less than 3,500 as well. It's not going to be easy wanting to set up physical tests. So you must attend our lectures so that when we decide to have online tests, you will be available to do the online test with us. Please try as much as possible to attend our lectures. I will see whether it's also possible. I know it's possible, but I've not tried it. I will see whether it's also possible to stream to Facebook as well, so that you have access to YouTube, you have access to Facebook information as well. As I said earlier, I'm going to post the lecture notes to you. This part is not complete, so I will send the lecture notes to you, and at the same time, let you have you have access to the YouTube channel. You can access the YouTube channel anytime that is convenient for you. Thank you for your time. I'll see you in the next class. And I ask Atunrashe to unmute. Atunrashe, yes. Unmute, Atunrashe. Unmute yourself. Yes.
I've omitted it. I've omitted it, sir.
Yes, go ahead and ask your.
Okay, sir. We are going to be having online class till the 29th of March next year.
Well, no, we just put that there. We are not sure of when the semester is going to end, but we decided to just book that. And the plan is to use one. I will discuss with my other colleagues to see whether we can use this same Zoom link that I've created for all the lectures, okay, so that we don't cause confusion for you.
Okay, sir. Thank you, sir.
Dennis, you're welcome. Dennis, unmute. Sembore.
That was the same question I wanted to ask.
Okay. Ibitoye. We thank.
Sorry, it was also the same question, sir.
Okay.
Sorry, it was also the same question I wanted to ask.
Okay. And we thank Ayola for letting us know that we did not stream online on YouTube when we started. Thank you for that information.
Yes, sir.
Okay, guys. So you have another and of this lecture. I assure you, we're going to improve on this. But let us know your feedback on what we've done this week. Thank you for your time.
Yeah, thank you very much, sir.
On Wednesday, I will look at the faculty timetable to know the exact time to come online and I will send it to you. Thank you for your time and bye-bye for now.